You know the feeling, we've all been there. You're cruising down the highway, just enjoying the drive, and then you're stuck, right behind a massive semi-truck. Suddenly your whole rhythm is off, you can't see a thing ahead, and you know you've got to make a move. So let's actually break down the surprising math behind what happens next.
Okay, so picture this. You're on the highway, holding a steady 70 miles an hour. The truck in front of you, doing the exact same speed. You've checked your mirrors, you see a nice clear opening in the lane next to you. It's time. You decide you want to get this done, quickly and safely.
So you set a goal for yourself. 8 seconds. That's it. From the moment you stomp on the gas to the moment you're safely back in the lane ahead of that truck. So what's your gut telling you? 80 miles an hour? Maybe 85? Well, let me tell you, the physics behind that simple decision is a lot more surprising than you might think.
All right, to get a real answer, we've got to turn this everyday driving moment into a little physics problem. And that means we need to lay down some ground rules and define what we're working with.
So here's our setup. Both you and the truck are moving at a constant 70 miles per hour. We'll say your car is a pretty standard 15 feet long, and that semi is a big one, 50 feet. You start out about 30 feet behind it. And that deadline we set for ourselves? A crisp 8 seconds. Okay, with these numbers locked in, we can start to map out the whole maneuver.
Let's dig into this a little deeper, because passing the truck is way more than just covering the 50 feet of the truck itself. To do it safely, you actually have to cover a much, much bigger distance when you think about it from the truck's point of view.
Think about it. From the truck driver's perspective, your car first has to close that initial gap, right? Then you've got to travel the entire 50-foot length of the truck, but you're not done. Then you have to travel your own car's length to be fully clear. And of course, you want to create a safe margin in front so you're not cutting anybody off.
So when you add all that up, the numbers really start to stack up. You've got the 30-foot gap you started with, 50 feet for the truck, 15 feet for your car, and let's say a pretty standard 75-foot safety margin. All told, that's 170 feet you need to gain on that truck. That's the real distance we're talking about here.
So how in the world do we get from that distance to a final speed? Well, for that, we turn to one of the most fundamental, most basic equations of motion. It's the one that describes how things move when they're accelerating at a constant rate.
And this is the magic formula. D equals 1/2 AT squared. Now here's the cool part. Since you and the truck start at the exact same speed, your relative speed is 0. So from a physics standpoint, it's like you're starting from rest. This little equation tells us exactly how far you'll go in a certain amount of time with a steady foot on the gas. You know, a really great way to visualize this formula is by looking at a graph. The distance you need to cover, that whole 170 feet, is literally the area of that shaded triangle. The bottom of the triangle is our 8-second time limit, and the height? Well, that's the final speed we need to gain on the truck. Okay, let's actually run the numbers. We plug in 170 feet for our distance and 8 seconds for our time. We do a little bit of algebra, and that tells us we need a constant acceleration of about 5.3 feet per second squared. Now, over those 8 seconds, that steady acceleration adds up. It adds a speed increase of almost 29 miles per hour on top of what we were already doing. So 70 plus 29, that gets us to 99 miles per hour. That's right. To make that pass in just 8 seconds, your car would need to hit a peak speed just shy of triple digits. I mean, that is way faster than most people would ever guess. But hey, the math, it doesn't lie.
But this is where things get really, really interesting. What happens if we just change one of those starting numbers? Let's say, instead of being right up on the truck, you're hanging back at what feels like a much safer distance.
So let's make that initial gap 300 feet. We're talking the length of a football field. But you're still feeling impatient. You want to blow past that truck in the same aggressive 8-second window. What does the physics demand from your car now?
145 miles per hour. That is a speed that isn't just dangerous and illegal, it's a speed most normal cars can't even reach. Trying to close a gap that big, that fast, is just a complete recipe for disaster.
I mean, just look at how these two scenarios compare. The total distance you have to gain on the truck balloons up to 440 feet. And to cover that much ground in the same short time, the acceleration you need more than doubles. This isn't just a firm push on the pedal anymore. This is flooring it hard.
This shows us that just trying to use brute force isn't the smart play here. The one thing we really have control over isn't our car's acceleration, it's time. A little bit of patience completely changes the entire equation and makes the whole thing safe again.
So let's rerun that 300-foot gap scenario one more time. But this time, instead of 8 seconds, we'll give ourselves a much more relaxed, much more reasonable 20 seconds to complete the pass. And just look at that difference. By just taking an extra 12 seconds, the acceleration you need becomes super gentle, just a light push on the gas. And the final peak speed, a much more moderate 100 miles per hour. Basically identical to our very first scenario, but you did it way, way more safely.
And you know, this is really the big takeaway here. When you're behind the wheel, you are operating inside a system of physical laws. And while our instincts are great for a lot of things, they are often a really poor substitute for understanding the cold, hard math of motion, time, and distance.
Now, of course, this has all been a simplified model. Real-world driving has tons of other factors, other cars, road conditions, your car's specific performance. But what this math really shows us is just how deceiving our instincts can be. So the question to leave you with is this. The next time you feel that urge to pass quickly, are you going to trust your gut? Or will you remember the surprising physics that says a little more time is almost always the safer, smarter choice? Drive smart out there and stay safe.